Hello, everybody. So we can get started now. We're just setting up the recording so we can put it on YouTube later. Thanks for coming for the SRE meetup here at Squarespace again. And today we have Jonathon Brouse, who's a solutions architect for Dodge Data and Analytics, going to talk to us about Terraform best practices. And I'll move to him now.
Thank you, Franklin. Okay. Hi. I'd like to start off by introducing myself. My name is Jonathon Brouse, and I help organizations ship and scale their products faster and cheaper with a focus on security and limiting unnecessary technical debt. Tonight, I'm going to show you how I do that with Terraform, an open source project by Hashicorp. Whether you're implementing Terraform in a brown field, implementing Terraform in a green field, or just getting started with Terraform, you're going to walk away tonight with something actionable that will make you more efficient and confident when applying your configuration changes. According to the Visible Ops Handbook, 80% of outages at high-performing organizations were due to changes. Whether you're practicing idle or have cabs, one of the major benefits of cloud computing, elasticity, can also be one of the greatest risks, because as easy as it is to create the resources, it's just as easy to remove them or destroy them. What Terraform does is to seek to create a software-defined data center and eliminate any unnecessary manual intervention. So by show of hands, how many have heard of Terraform? Anybody? Okay, how many have used Terraform? How many are using Terraform in production? Okay, awesome, cool. For those of you who haven't used it, it's basically a small compiled binary that you just run from the command line. Terraform enables you to safely and predictably create change and improve your production infrastructure. It codifies APIs into a declarative configuration file that can be shared and treated as code and versioned. Terraform does this by using providers. A provider is responsible for understanding the underlying API interactions and exposing resources. By supporting multiple providers, Terraform stays agnostic to the underlying platforms. This is just a handful of the providers. There's over 50. I stopped counting because I just was wasting my time. One of the arguments that I hear of CloudFormations versus Terraform is that CloudFormations is an AWS product. They theoretically, you'd think that they'd have features implemented faster than a third-party company, but one of the things I wanted to point out here is on April 5th, AWS announced host-based routing support in their ALBs, and just a few days later, Terraform was able to push out a release that exposed that resource as well. So pretty quick turnaround. This is a tweet from Michio Hashimoto, who's founder of Hashicorp. And I don't know if you can see it, but in the first quarter alone, Terraform had 11 releases, which is unbelievable. They have a changelog on GitHub, which I get emails, and it's probably the only thing that I religiously read when I actually get the emails in, because there's just so many new things being added to this tool. So now we've kind of got our hands around what Terraform is and what we can do with it. I'm going to dive a little bit into some code, some examples. Here's our first configuration block. We use it to configure our providers like AWS. You can specify credentials. In this example, we're specifying the region in which AWS will be creating the resources in US East 1. The next configuration block is a provider, or excuse me, is a provisioner. Each provider has their own sets of provisioners. The first section of the provisioner is the type of resource. the second section is the name. You can name it whatever you want. I named it this way. And we'll talk about this later. I'll show you the reasoning for that in a couple of slides. But basically, we're creating a Route 53 zone, and we're giving it the name specified here. It's sysadmin.host. The second resource that we're creating is the the Route 53 record. And we're using what's called interpolation. This type of interpolation is resource interpolation. It's using the attribute that the Route 53 zone created. When resources are created, Terraform stores the resources attribute values to be reused in other resources or passed out as an output variable, which we'll talk about as well. When we're going to actually run Terraform, it's a good best practice to run Terraform plan to see what changes would occur if you were to actually apply this configuration. The one thing I wanted to point out at the top were plus symbols. Means obviously we're creating infrastructure. If we have a minus, we'd be removing it. If we have a minus/plus, we'd be destroying it and then recreating it. If there's a tilde, we're going to update the resource in place. Something to keep in mind when you're looking at your output. So we have our first module. Basically, any directory that has a Terraform file in it can be considered a module. When we ran our Terraform plan, that's considered a root module because all of the modules self-contained in that directory. We can store these modules in the directory path or Git repo, S3, or an HTTP endpoint. But one of the goals of the talk was to create dry modules. So dry is don't repeat yourself. Wet is we enjoy typing or waste everybody's time. So we're going to parameterize to stay dry. And a couple of the highlighted parameters we're going to create variables for. So we don't have to copy this file around, make changes to the file, create branches, etc. So this is the second type of interpolation, variable interpolation. One thing to note, you can't interpolate while you interpolate. There's no nested interpolation, so there's only one layer that you can declare. And also, they can be used with strings as well in naming a resource. This is how we declare variables or define variables. I usually create a variables.tf file and specify the variables that I want to declare. This is the example output from a Terraform apply command. So this is when we're actually going to create the resources and instantiate the modules. This is the second half of that. So we're going to create two resources here. And you see at the bottom there's outputs for the resources that we're creating. So I wanted to throw in some eye bleach so it's not just lines of code that are getting burned in to your eyeballs. So now with that, back to our program. So the outputs at the bottom there are created from within the module. They're called output variables. We can specify these output variables in an outputs.tf file. Here we're using the resources attributes via interpolation. We can also use the variable interpolation as well to create output variables that other modules can use via the output state file. And if it's a little confusing, we're going to talk about it a little further and dive a little bit deeper as we progress. But one thing I wanted to note was using variables here as output variables. You can use these in your state file to implement Terraform in a brownfield by referencing state the same way that you create the variables. And I'll point that out as we progress here. So version 2 of our module. It's dry, it's parameterized. We have variables, input variables that we can pass in. We create output variables that we can use through other modules as well. Wanted to take a small little detour from the modules and talk about style and how it's more than just looks, how it can reduce the complexity of Terraform configurations. The first way is just file naming. If you notice, I usually break out everything into separate files. Here I create separate files for each resource that's being created and keep any resources that are similar together. So in our route.tf file, we would create the route tables, route associations. Similarly, we can use this for IAM and keep our IAM roles and instance profiles and whatnot in a single file as well. You can cat these files together to help follow the interpolation path, and it's also good for new people who come into the organization or people in GitHub who take a look at it and can see exactly what your module is doing and what you're creating. Also, you can move it to .tf.disabled to prevent it from being created without having to comment code out as well. So it's a side benefit there. So the next style guide, kind of best practice, would be resource naming. This to me allows you to limit complexity. When I first started using Terraform, I was like, did this have a dash in the name? Am I using an underscore? Is it this Bob security group? So by limiting it to just what the resource is, reduces the complexity, allows you to reuse it as well if you want to copy and paste it to other modules. And basically, just don't treat your resources like pets. So if you're creating multiple resources of the same type, for example, here we're creating two S3 buckets, one for some type of data and one for images, we would just give the resource a minimal identifier that we can easily remember. So as I mentioned earlier, I had some problems when I first started of when am I going to use underscore, when am I going to use hyphen. Decided to just stick with variable naming, anything that's interpolated, and just have the discipline to use that throughout any modules that are created. On the other side of that, any resource that's actually created, EC2 instance, Route 53 entry, will have a hyphen in it. Just so it also looks nice when everything on your console's similar. This is another command. So we ran Terraform plan. We took a look at Terraform apply. This is Terraform format. It not only checks your syntax and makes sure gives you any errors feedback, but it also aligns your configuration blocks as well, which is extremely helpful, and it's one of the first tools that I've used as far as configuration management that does that. So it's a godsend. I love it. On a side note too, the documentation is pretty awesome for Terraform, but another benefit is the collection of resources that you can view. All of AWS's resources is on one page in Terraform documentation. So you can just look and drill down and say, oh, I'm going to learn about Kinesis. And whereas AWS's documentation is like a lake, this is more like a fishbowl where you can go, let me take a look at that, and then you can go over to the lake and read more about it. But it's definitely allowed me to learn a lot about AWS, just a side benefit. So we covered some syntactical ways to help our reduce complexity. I'm going to go back to our modules and see if we can improve our module that we have here. So here's where I kind of start making stuff up. The service module is essentially a reusable library. So Terraform package that creates all of your resources that you need for your service. And the service doesn't need to be, say, an image manipulation tool or some other microservice. It can be VPC service. But the concept is that it's just a single package of Terraform configuration that creates all the resources for you. The other one is an infrastructure module, which is all contained in a single repository. They're a collection of root modules. So this is where you actually instantiate your modules and you pull in your service modules. And we can reuse the modules here over and over again and create our different environments. So why do we need an infrastructure module? Conditional statements are painful to say the least. As I said earlier, you can't interpolate interpolations, and also to segment state to reduce the risk of changes. I don't want to have my VPC, which is relatively static, in the same state file as a service I'm going to deploy 100 times a day. Also, Terraform's environments, they've said in their documentation they don't recommend this use yet, but it's nice to see them starting to head in that direction. Yes?
What was the 1604?
Oh, sorry, that's the Git issue that introduced the conditional statements. So I just threw, there's a couple other Git issues in here, just if anyone's curious about learning more about it, but just as a reference to see why it's painful, you guys can go to that issue and read about it. But thank you for pointing that out. The candle problem. Has anyone ever heard of this before? So I stole this from a talk that Dan Pink did. So imagine I'm an experimenter, and I give you a candle, a box of thumbtacks, and a book of matches. And I say, attach this candle to the wall in such a way that when you burn it, the candle wax doesn't drip onto the table. So people started to use thumbtacks to try and attach it to the wall, tried to light the candle and make it stick to the wall, but all those are good ideas, but it didn't work until they overcame the functional fixedness of the box of thumbtacks. The box is not just a receptacle for the tacks, but it's also a platform for the candle to sit in. So what does this have to do with technology at all? So I'd come up with the solution, and watching that talk, I was like, this is like perfect, because I create a repository that stores all of my infrastructure in this hierarchy. So why not leverage this file structure to create the remote state location, or to seed my modules with variables with the structure here? Grails has an idea of convention over configuration. This is configuration by convention. Kind of a spin on that. So now we're going to kind of go into some greenfield provisioning, take our module and yes. This? So I'm gonna talk about this. This is part of the greenfield provisioning that I'm gonna talk about a little bit more. But this is essentially a folder structure in one of your Git repositories. Mm-hmm. So we're gonna use that process to create our resources in a greenfield here. So what we had already done was we created a DNS zone and DNS entries in our root account module. Right now we're going to add a backend and a remote bash script. So to achieve this dynamic state creation, I had to create a small bash wrapper that dissects the file path. So here's a small snippet of that, and it will take the directory that it's in and add it to the key of your state configuration. So we're going to output our state file into an S3 bucket with the bucket name being the account that we're in. Does that make sense? Is that okay? Thank you. Whoever said yeah. There's some recently, Terraform, Hashicorp introduced base name and dir name to start to go this way, but to break it apart, the interpolations are just like, I haven't figured out a way to do it. So if there's a way that anyone can figure it out, definitely drop me a line. And the backend configuration was recently introduced to be able to configure your backend in Terraform file and not have to specify it each time you run the apply. So that was the motivation behind writing this bash script, because there's no way to put that into code and version it. So I'm slowly trying to migrate to this and deprecate some of that bash script, because I'd much rather use native tooling. We just talked about the resources that we created at the AWS account root module. We can skip over the US East root module because we're not creating anything at this level yet, or tonight. Right now, we're going to focus on working in our production US East 1 VPC. So this is a root module where we can instantiate a VPC module. So these files will live in that infrastructure repository at that folder level. And these files will essentially be the files that you'll put in each of your your root module directories. So this is the first example of actually pulling down a module from a remote location. Here we're pulling down a VPC module from Git, and you'll see we're passing in variables that are defined in the variables folder. We can also specify a branch, so it allows you to you create branches and versions and deploy specific modules out to specific environments. Here we show interpolation of branch variables in our source definition, but we can't actually do that. You can't interpolate at that source definition yet. So there's another issue, 1439. They're at like 123,000, so maybe it'll happen sometime. But you can pass in variables into the module. And we're going to take a look at passing in public subnets. So here's a small snippet from the variables file. We're going to create a list of our subnets. So this is the second type of variables that we're looking at. The first was just a string. This is a list. And another type would be a map, basically a key value pair. So we're going to pass those variables into our service module, in which we instantiate via a Git source. When we create the VPC, the attributes that are created can be published or presented as output variables in your state file, so other modules can use them. What we're doing here is we're creating the service module that's creating an output of our public subnet IDs. So our root module, which is where we instantiated the VPC, can use them to create an output variable that other modules can use. So to kind of go back one more time, we have our root module, root VPC, in our infrastructure repo, calls out to Git, pulls down that module. That module slurps in the variables that we give it. It creates the resources. Then we have to pick out which resources that we want to create outputs for, and then those outputs are presented to our root module in our infrastructure directory. In our infrastructure directory, we can say, okay, we want to use these resources as output variables and publish them to our state file. So then when another resource wants to use those variables, they just look at the state file that was created for the VPC module. I'll give you a visual representation of that in a couple slides here. So you can you can take this into your architect and you can say, hey, I have an awesome way to create root modules in an infrastructure repository and call in these service modules and then pass in state and create all this with Terraform. And I've gotten this a lot in my career, like just whoa, just hold the phone. If you're working in a brownfield or the best way to introduce something is with small incremental changes. So when I first started using this, I messed up my slides. So when I first started using this, I used a thing that I'm calling state seeding or scaffolding. What you're basically doing is you're kind of mocking out those resources that can be configured with your VPC module. You're probably saying, John, Terraform allows you to import these resources, but the one advantage with this is you're basically creating a backup of your infrastructure if you do it this way. If you go in and delete your VPC, you can't import those resources anymore. So this basically just goes in and passes the variable that you've handwritten to an output and publishes that to a state file. Those two files together don't actually equal an infrastructure change, so your output won't ever be published to state. So what a coworker of mine, Brian Deal, helped with was just put these as dummy objects in the state file bucket to force the output to be published or presented. My apologies, the slides are a little out of order. So now that we have a VPC module, a VPC that was created from our root module, we can go into our environment. Now this is basically just basically just an outputs file, excuse me. So this set of parameters are going to be used by our service modules to look up state, to publish state, and really just this one place is where we ever need to add files or make any changes to our infrastructure when we're rolling out services. So we're at the home stretch. All right, so this is an example of a root service module. So here we're just creating a jump box. If you look at the top, we are referencing the environment module, which is just those outputs from the parent folder. We're also pulling down the module from Git. And when I mentioned that we only need these variables passed in to create any type of resources, this is what I meant. So with these resources, I'll show you in the next couple slides how we just take these and create really any module that we need. So we're there. So here we're adding a data.tf file. Now this is where we're going to put the resource to hit our remote state data. So if you take a look at the keys, we passed in the region, we passed in the VPC name. We also passed in the account for the bucket name. We can pull any type of information from the VPC state file through this type of dynamic construction. So hopefully it's something's clicking, maybe I see like one or two, but you take your folder structure apart, you pass it into your module, and in turn, it allows you to access any of the resources that you need. Now, if you had an RDS instance, you could also reference that RDS instance as well. So you have, service A-RDS state file. You can create a data stanza for your, or data block for that RDS instance and add yourself to a security group that it's spun up. Same thing for the account. Here we're going to pull down the zone ID that we created earlier, just by dynamically deconstructing our file path. So here's the example of using that zone ID. We reach out to our remote state location via that resource that we created in the previous slide and pull down the zone ID. We do the same thing with our security groups here. That's not supposed to be security groups. Sorry, it was late, kind of mucking up this last part. But the general gist is being able to pull down the resources, the VPC ID, from the VPC module. So, kind of in closing, does this make a little more sense? Kind of a little bit, kind of? Okay. So this design pattern allows you to manage state and variables dynamically by taking apart the folder structure and the directories that you're in and passing them into your service modules. So a couple improvements, some things that I like to work on or like to see is, of course, the interpolation of variables and modules and sources, which should allow us to specify just parameters when deploying, say, through like a Jenkins job or anything like that, instead of having to hard code them. The base name, dir name interpolation will be nice to remove that bash script dependency, and then using tools like Kitchen to test your code before actually deploying it. So going over the agenda is a brief introduction to Terraform, kind of warp speed, bringing you up and how to use Terraform, how to reduce complexity with styling and making choices about how you name parameters and resources, then writing dry code with modules and implementing those through infrastructure and root modules. So I hope you enjoyed. That's the end of my talk. And what questions do you have for me about Terraform or this?
One sec, I'll give you the mic.
So you mentioned using Terraform format and not apply, but something that would tell you what changes are going to be made. What other testing do you do before you actually apply?
Sure. So basically, what other questions do I do besides the format do I do before, and the plan before I apply? Basically, it's just the plan. The slide at the end there is, I guess, an admission of the lack of testing when code is being committed, but the plan gives you a good sense of what's going to happen when you apply those resources and whether or not you should or you shouldn't take action.
Hi. Are you aware of any general scripts or tools that can help in terms of Terraform refactoring? Because sometimes as you're moving through versions or like rewriting modules, you would like existing resources to be moved into sort of like maybe a new module that you're writing, and just dealing with the refactoring around the state there.
So you're wondering if there's any tools that you can use to help refactor the code to upgrade it, I guess, essentially. Is that?
Well, yeah, it really should be a two-part question, but I guess mostly around sort of like rewriting modules and porting existing resources. You don't want to make any changes. You would like those resources to be moved to sort of like a new module that you're writing. So really just like refactoring state files is what you're dealing with there.
What I would do there is rely on branching strategies. So essentially just take a snapshot in time of that module and reference that branch when you're spinning up new modules or new instantiations of that. I personally don't like to muck with state or anything that Terraform creates. that's why I create an outputs and a variables file to create that scaffolding in front of it instead of changing the state by hand.
I have a couple of questions, if you don't mind.
Sure.
First, how do you split up your modules in Get? Do you do a module per repo, or do you have just everything in one repo?
So the question is whether or not I have
A repo per
a
module.
single module, yeah, per repo. So it's, I guess, a combination of a couple things. I usually try and like to keep the configuration code with whatever application or service that it's running with. So if it makes sense to store that code with the service that it's working with, then I usually put it there. But if it's just a VPC module, I usually keep it, let's say, for example, in Bitbucket in just a Terraform project. So anything that isn't related to any other service, I keep in a module itself.
Okay. And the other question I had was, actually, I already forgot what it was. So when you, how do you, you have, how do you use variables, environment variables? So if you have, let's say you need to create multiple networks, and it's the same root module, but you need to pass in different variables, and obviously you need it to be in different state files within S3. We use S3. How do you just duplicate that root module and just have it in different folders with different S3 backends, or do you have some other way of kind of, so you don't have to duplicate or have it multiple times, the root module? I don't know if that's clear. I could
I'm trying to.
So let's say you need to create a whole entire VPC from scratch, and you need to create multiple AWS accounts that are different.
Mm-hmm.
Instead of having to, right now I have to multiply, each time I need to create a new VPC, I have to create the root module, which references all the other modules like VPC and security groups and so on. And so I have to have now multiple folders with the same code. If I need to then go and change the root module, I have to go and change it in all those places.
Yes. So this approach doesn't take the standard kind of best practice of splitting the network and the compute and in different folders. This, in your root module, you'll basically just say, hey, I want a VPC, and then it'll just go and make a VPC. You don't worry about, okay, I need to create flow logs with this module, and I need to create subnets with this module. It's all encompassing. Now, there are some limitations there, right? You have to have a standardized module that, okay, this module is going to create X, Y, and Z. You can always add other modules alongside that, but generally, I usually say, all right, this is what our VPC is going to look like, and then just kind of copy and paste that environment stanza and that module declaration, and just put those into different directories. So you had mentioned with different accounts. At the account level, I usually create separate folders for each account.
Okay.
So the neat thing with that is when you pass in the account, the provider, I don't think I actually put it in here, it's just something I recently started doing, the provider can be your account name that you passed in. And then in your credentials, in your AWS credentials file, you can just name it your account. So you can go to separate accounts, and it'll automatically pass in your account name and use those credentials on your system. Does that make sense?
So you would store you would have different S3 buckets for each state file for that account? Is that what
I would have a different S3 bucket for each account.
okay.
Yeah.
Okay.
I mean, you could have cross-account roles, but yeah, generally that's just to keep it simple. Different buckets and different accounts.
Just had one more question. This might be slightly out of scope, but for example, when you're creating like an RDS instance, you may need to specify sort of like sensitive attributes like, the master password. So how do you personally deal with secrets in Terraform?
So I don't. That's another one of the disadvantages. I don't muck with that at all. There's no way I'm going to put any kind of secrets that could potentially be exposed because they are in clear text. So the thing that I normally do is I'll put it in and pass it in as a variable, or just for that one initial run, create the resource, and then pass it in again with no password. I think that's how I did it. But long story short, I don't. And that's definitely a concern.
All right, any more questions? If not, thank you very much, John.
Right, thank you.
There's still plenty of food left. There's beer in the back, and we're gonna try to keep doing this every month. And if you want to speak, or if you know anybody that could be a good speaker, please email me. You can find my email in the meetup group, and we can schedule them to come speak to us about anything SRE related. And thank you very much for attending.